Hi, we're going to submit. Please submit because we're going to discuss. So because I want to see the distribution of your grade, then that would be a let me show you the distribution. I mean, that would be interesting because I guess that would be seeing how well you and your you see this pretty good. So you can see most of you are getting a pretty good score, right? Answering 80% to 90, 70 to 80% of the question, and then this few of you need to some improvement. But let's go over the answers, the question answers. So just to make sure you see my screen. If not, then please tell me. May I have confirmed that you oh yeah, that's great. So you're seeing this. So we'll quickly go over the questions and then we'll break. Then we come back with continuous distribution. So very quickly, this is a question about the daily accident. And what we have here is the question 1 and question 2 are related. The first question is asking the mean, and second one is asking the variance, right? I hope that is not a big deal, but you can draw a table. There are 3 possible values for x, right? And by that, the value of x can either be p of x is either 0.3, 0.2, and 0.5, right? So expect the value of x is just right, 0 times 0.3, 1 times 0.2, and 2 times 0.5. That gives you 1.2. Okay, so that is the answer E here. Okay, I hope that is clear. So then this question 2 is again the very same question, but asking the variance. Okay, the variance, okay, would be just each value you minus the mean, right? So we just 0 minus 1.2 square 0.3 plus 1 minus 1.2 squared 0.2 plus 2 minus 1.2 square 0.5. Okay, so at the end you get the answer close to 0.76, or the answer is B. Is that okay for the first 2 questions? Is that okay? Good. That's great. So we go to the second question, Q3. So this actually not too much different from the first question, except that this is the distribution of x, right? X has value of 1, 2, 3, right? The p will be 0.2, 0.3, 0.5, right? You can easily follow the same logic, calculate exponential of x, actually give you 2.3, okay? And the question asks you 100 kg, so it's asking the question of this, okay? So it will be 100 expected x, so that's why it's 230, okay? So the answer is C. Is that okay? Okay. So 4 will be a little bit trivial because asking the mean of binomial, which is just n times p. So we just 8, answer C. Okay. The next one will be variance of binomial, right? And then we know it's np times 1 minus p. Okay, so that's why it's 10 times 0.8 times 1 minus 0.8, which is 0.2. So it's 1.6. Okay, I guess that should not be a big issue for you. And this random variable x has a binomial distribution n equal to 4 and p equal to 0.2. What is probability x is greater than 1? Okay. So the answer should be right, probability that x is strictly greater than 1. So that's a key point, strictly greater than 1. Okay. And then will be equal to the complement, which is less than or equal to. So that's, you have to be very careful about this part. So this is strictly, so the complement will be less than and equal to. And for this, right, x can start from 0 up to 4, right? So x less than or equal to 1 actually consists of two parts, x equal to 0 plus x equal to 1, right? Because they are mutually exclusive, so it's a partition, so we just add them up. And this is what? This n is 4, p is 0.2, so it's 4, c 0, okay? 0.2 raised to the power 0, 0.8 raised to the power 4, okay? For this one, it's 4c1, 0.2 raised to the power 1, and 0.8 raised to the power 3, okay? Add them up, and this is 0.4096. This is 0.4096. So do the calculation, add them up is 0.1812, and then subtract from 1 is 0.1808. Is that okay for this question, question number 6? Is that okay or not? Okay, good. So question 7, that is about sampling, right? Sample 40% on pad, sample of 5, okay, and exactly 3 on packs, okay. So here you have to be careful. Is this one is asking sampling with replacement, in the sense that when you draw the first student, you expect the probability is 0.4. The second one is also 0.4. The third one is also 0.4. Those are the last one, right? So that's why it's independent trial. Each drawn, you believe that the student would like pack is 40%, right? So that's a binomial with n equal to 5, right? And p equal to 0.4, right? So asking is the probability that x is exactly 3, okay? So that gives you 5 C3, okay? 0.4 raised to the power 3 and 0.6 raised to the power 2, okay? So the answer is 2.34, so that's why B. Is it okay for this one? Okay, good, thank you. So question 7, question A. Question 8 is rather simple. Poisson, the mean is 10, okay? The variance is also 10 because that is the Poisson and the have the same mean and variance. Okay, there's nothing to say anything more. Question number 9 is about Poisson again, but now we're calculating probability. Okay, so we have a Poisson. Okay, a number protest of Poisson is 10 per day. Okay, so lambda is 10. Okay, and what's probably 8 or 9 protests in a day. Okay, so it's still a day, so that match. Okay, so in a day, that means that the mean is 10. Okay, and what we want is probability that x is 8 or x is 9. Okay, and we know that 8 or 9, they're mutually exclusive, so that's why it's or will be equal to the sum. The reason why is you should do this, right? If you general will be x equal to 8 and x equal to 9, right? Because this is a addition subtraction rule, but this cannot happen, right? This is 0. And this is Poisson, so it's e to the negative 10, right? 10 to the power 8 over x factorial, right? E to the power negative 10, 10 to the power 9, 9 factorial. Add them up, okay? This is 0.12, this is 0.125, and add up will be 0.237. So it will be A. Is that okay for this question? Anyone under? Okay, so I'm going to the next question. 10. So it's 999 call in a small city following Poisson distribution with mean 4 in 30 minutes. Okay. So probably 2 or more in an hour. So I deliberately make it trickier because now it's not the same. Okay. So 4 in 30 minutes, right? Means 8 in an hour. Okay. I did really make it more difficult, but hopefully you understand why this case, right? It's just proportion, right? It's like, it's because it's an independent trial. So an hour, we just say proportional to what it happened in 30 minutes. So the question is asking probability x 2 or more. So it's bigger than or equal to, okay, 2. This is, you cannot list them all because Poisson is going to, from 1, right, from 0 to infinity, right? So you cannot easily get this. So that's why you need to do the complement, right? Because you can't really list them all, right? Complement will be less than 2. But less than 2 actually has 2 parts, right? Is 0 and 1, right? And 0, according to Poisson, is e to the negative 8, x to the power 0, 0 factorial, e to the power 8, x to the 1, and 1 factorial. And the answer is like this, very small numbers. Turn out you are very close to 999, right? So that is idea E. Is that okay? Good. 10, okay. This question I make it because a lot of you are auditor, accountant, right? So that's why I make this question. So here I have a warehouse utility box, right? 6 of them are full, 14 empty, okay? May not be full empty, can be say they have inventory, they don't have inventory, right? So, or they have less inventory than usual, right? They just put empty thing there, okay? So 5 boxes are drawn randomly without replacement. So immediately out of your mind, you know this is going to be a hypergeometric one because you drawn without placement. So what's probably exactly 2 full bars are drawn, okay? So this is called success, right? So here we have n equal to 20, right? And n is equal to 5, right? Because we're going to draw 5 sample, and a is going to be 6, right? So n minus a is going to be 14, because 14 empty. And you're going to draw is 2, okay? So what you want is the empty one, exactly full is 2, so empty one is 3, right? So the probability again, x equal to 2 will be ACX 6, 2, NAC n minus 6, 14, 3, big N C small n, 20 over 5. Okay, just calculation give you this. Okay, so that's why the answer is B. Is that okay? Good. So let me go to the very last question, and then we have a short break. So we have a drawing playing cards, right? 52 cards. I hope everyone would know what it is. Is half of them are black, half of them are red. Okay, you're going to draw 5 cards. Okay, and what is probably exactly 2 red? Okay, so n is 52. Okay, you want to draw 5 cards. What is called success? Success is the red one. There's 26 of them. The not success, there are also 26 of them. Okay. And how many you want? You want exactly 2, so 2. How many black you want? 3. Okay. So here the probability that x equal to 2, right, will be ACX, so it's 26, 2 here, and NA minus 6 will be 26, 3 here. The denominator will be 52 over 5 here. Okay, so you calculate, this is your answer. So closest to this one, okay? Of course, someone asked me why I didn't write this. Doesn't really matter because there's no risk of confusion, right? Whether either a truncate or round up or round down doesn't really matter because the best answer is closest. Okay, any question?
Yes.
Yes, please.
Can you do question 11 again, but change the question to with replacement?
Oh, okay.
Yeah.
So let me. First, is it okay for question 12? Okay, then
yes. Yeah. Thank you.
So if I ask this question with replacement, then actually this become a binomial, right? Okay, this become binomial. Okay, so here I have n is 20, right? A is 6, right? So if you draw just one, the probability that you successfully drawn is A over n, right? So it's 6 over 20 is 0.3. Yes, it's 0.3. Okay, and then here small n is 5, right? So it's a binomial with n 5, p 0.3, and you want x is 2, okay? So if you do it with replacement, okay, it will be 5c 2, okay, 0.3 raised to the power 2, and 0.7 raised to the power 5 minus 2, which is 3. Is that okay? Hello?
Yes, okay, thank you.
Okay, so that's the difference between the replacement or without replacement. Any further question? If no, with a break, 15 minutes break as usual, because today we start on time, so we should have an on-time break. So we will be doing for this 5:37 p.m. So we come back. In the meantime, you can ask me question if you like. Let me pause the video. We will come back with the video record. Okay. I think we should resume the class. So, can you see the screen? Can you see? I hope you can see. If no, then let me know, because I can't really see the chart in my screen. So let me see if, okay, you can see. Okay, so let's get ahead. I don't know why. Oh, you see it. Okay. So let's continue the continuous random variable. We are going to finish this set of slides next class. So a little bit behind the schedule, but I guess probably we don't need to worry too much about it, because of the this year probably we might not have enough time to do in-class presentation. So we have extra time anyway. But anyway, let's get started about a continuous random variable. So I think after the quiz, then probably you know very well what is discrete random variable. So now we go to a continuous one. Remember, continuous is something that you cannot count. Okay, there's no way you can count of them. So that means first implication is, when we learn from the random variable, discrete random variable, right? You can say 0, 1, 2, we can list them all out, right? And then we can say some probability is what. That's no longer feasible here, because now it's no longer just some discrete number, but it's other continuous. Okay, and that's why when we talk this, we start with the big F, the cumulative one, which we can say something about that. Okay, cumulative is asking what is probably x is less than or equal to small number x. Okay, in that case, we know more how to say those things. Okay, because this is pretty easy to define. Okay, and remember, this is in the case of discrete, right? This is add them up what is before it, right? Which is summation, right? P of x, right? For all x less than x. right? So it's this, okay? And now continuous, so you no longer use summation, but you use the integration. But integration just add them up, right? Add them up, add up what? Add up certain thing, but we don't define it, okay? It will be defined here, okay? So we define integration of the, what we call the density function, okay? This is called the density function, okay? Okay, or sometimes called probability distribution function, okay? And what this function is of course defined as the differentiation of that. That is from the fundamental field of calculus. But what it means is if you draw this function, okay, x, this is f, right? And what it means is, okay, by the virtue of this, if I want to say there's a and b, there's two number, okay, and there's f, okay, the area, okay, under this curve will be the probability x is between a and b, okay. So that's why this f is called density. Is borrowed from the physics, okay, physics idea, okay, density, and then you integrate, become a mass, right, and then it become probability mass. So that's why it's borrowing from physics. So this f under the curve of f, okay, with a and b, right, and that means the curve under the f at most one, okay, at most one. So this is a property you need to know, okay. Is there a question? No, okay, just definition. So there's nothing, but just, well, we're just counting number. So we just say integration. You integrate certain thing. You can integrate x. Doesn't really matter. Just a variable to be counted. Just like the summation of xi, I come from 1 up to n, and this I is just the dummy variable, the counting variable. What he said is just, okay, just go a little bit deeper. So this function f, right, take the value, you can imagine this v is here. See, this is v, right? Okay, let's have some calculus class here, f, okay, and the height is called f of v, right? And integration here means I do the basic integration, the Riemann sum. So this is dv is a change of v, this a very small dv, okay, and dv times fv will be this rectangle, okay. It just add all the rectangle up with the area, okay. So that is the idea of integration. Have you ever learned this, Hui? No. But what it means is basically the area, this area of the curve. This is the height. And this is the width. Yeah, I know you didn't learn it, but we didn't require you to know it. But their definition, I don't know how we can escape from that because continuous is have to define this way. I know you haven't learned it, and we don't require to know it. What you need to know is if I have this density function, okay, the area under the curve is probability. That is the thing you know, and that is the meaning of integration. But you just need to know the meaning of the area, and the integration is to calculate the area. But you don't need to know the integration, how to operate integration. But that is the only thing. I hope I make myself clear. But but we don't need to do calculation on integration. We will demonstrate some proof using integration, but integration is not needed for the class. Did I make myself clear? Just to repeat, what you need to know is this cumulative is a big F, okay? This big F can be defined by area under the small f, okay? That is the thing, a small density, okay? That is the main thing. And cover area under a curve require you to know the integration, but for our purpose, it's not needed, but you need to know its area under curve. But that is the goal of this slide. Okay, I'm sorry for integration, but I don't see any way to escape from that, because that is how we define probability density function and so on and so forth. But for the purpose of calculation, all the things we don't really do integration. Anyway, I hope there's any further question. I mean, very good for asking this question. Thank you. Okay, if no more, then we go ahead. So again, I just show you the notation, but we don't really need to worry too much because we are not doing this. But this is just, you can imagine this is just probability, right? So this is just y times probability y. Sorry. So this is the probability, this summation, okay? So there's no different from that, okay? And this is just summation, okay? And just y ey square, and this is just probability y, okay? So that is exactly the same thing, but in the integration form, okay? And for those of you who are afraid of notation, it's okay. When I were you in, I think 16 years ago, I also faced this question, why is integration, right? Although I learned integration in high school, but I still feel a little bit weird. But it's okay. I mean, it's more like some problem, you live with it, and then you feel comfortable enough, long enough, then you'll be okay. Okay? So it's okay. You just have it for a moment, then you will notice, actually, this is the very natural way to do things. But for the moment, just let it be, and then sooner or later, you will adjust to it. But anyway, just definition, we will not use it except for definition purpose. So we don't do too much calculation here compared to the discrete version. Okay. So that being said, so now because the general case is involve integration, which we don't, is not the goal of this class. So what we are learning is we will learn how to operate this using certain focus on certain type of distribution. Okay. The main goal here is to focus on normal. Okay, that is the main goal of this class, and this turned out to be super useful, and you will be basically using this for the rest of our course. Okay, we'll be using normal, and his friend standard student T. Okay, this is friend. Okay, I would say his best friend. They would be working together a lot of time, and normal has a brother called chi-square, and we will talk about definition of this, but formally, normal is, if normal is x, chi-square is x squared. Okay, and student T is very close to x over some square of chi-square. Okay, so it's related in this way. That's why they're brother. And chi-square has a twin called F, is chi-square over some chi-square. Okay, So all this, okay, will be very useful for the second half of this class when we talk about estimation, hypothesis testing, regression, ANOVA are all based on this, okay? But of course, for this class, we only cover the normal. We will give you very brief what they are, okay? But we will not go into detail until we really facing them, okay? And for the purpose of other application, we will talk about uniform and exponential because they have a lot of applications, okay? But the emphasis is in the normal, okay? Because normal, later you see next class will be somewhat very common. And for those who learn finance, normal is a one way to model assets return, okay? But anyway, let's start, okay? If you don't have any question, okay? And we learn some common distribution, okay? So uniform here, okay? Uniform is the most easiest one. And we start from here, then you know how things being operate, okay? Although it's not uncommon to see uniform, okay? And when you don't have any idea what's going on there, uniform will be the most natural way to model, right? Suppose you don't know what should be number of customer to arrive tomorrow, but you will be expecting some customer maybe from 10 to 20, right? Then the best model might be using is uniform, okay? Well, that is something usually when you say, right, go to the TV, right? And also we ask the financial analyst, right? They said, oh, tomorrow what's Hang Seng Index, right? It's around from X to Y, right? He will give you what's the highest, what's the lowest, right? But do they give any distribution? They don't, right? So usually what you expect is that they don't give, and then the best bet is they are thinking about uniform, right? So that is uniform is equally ranged, right? So basically, if it's from A to B, right, is saying that any number between A to B will be equally likely, okay? And if you put any same length interval, that also be equally likely, regardless of where you pick the unit interval, okay? So, how to calculate probability, right? First thing is the density function, right? The density function, remember, right, is area under the curve will be the probability, right? So A and B, okay? If they are uniform, it should be the case that it should be flat, right? It will be somewhere, there'll be area under here, there'll be no area outside, okay? And remember the probability will be the area, right? So it means that no matter where you, which part you pick, right? Suppose you pick this portion, okay? And you pick the other portion, okay? As long as they're same width, then they have same probability. So it must be a horizontal line, a flat one. And how high is this line, right? This line should be 1 over b minus a. The reason is because this rectangle, okay, must be 1, okay? And the length of this is b minus a, okay? And multiplied by the height must be 1. So that's why we give density function is 1 over b minus a, okay? That means that give you this function is very useful because if I ask you, okay, suppose A is a, I don't know, let's use Hang Seng Index as approach, right? So suppose a analyst said, oh, tomorrow, I don't know what it's now, okay, just make up some number. So tomorrow maybe 23,000 and 24,000, okay? Okay. I don't know what the number currently is, but anyway, just make up some number. So it's uniform between this 100 point, right? So asking what's probability that is between 23,055, right? And T3550, say suppose, okay? So what's probability of that? Then it will be, okay, the difference, right? So you can just look at this, okay? It's 23000 and 24000, right? What's the height here, right? This is 1000 here, so it's 1 over 1000, okay? Because B minus A. And the area will be 235,000, right? And 235,500, and this is area, okay? The base of this rectangle is 50, right? The height is 1000, okay? And then you just simplify, so it's 5, okay? 0.05. So it's 5% that will within this range, okay? So that's how, if this is uniform, this is how the density function being used. Is that okay for this one? If you're okay, can you leave okay in the chat? Good, thank you. So the next thing is about the distribution function, right? So we just add them up, right? And for those of you who learn calculus, this is just a simple integration, right? But as we said, we don't require you to learn integration. So basically, it's just area, right? Because you are calculating area from A up to X, right? Suppose this is X, right? And the base of this rectangle is X minus A, right? The height is 1 over B.B.A. So that's why it's the base times height. So that's why this is the answer, okay? Of course, if you are really serious about math, you can just integrate, give you the answer, okay? I'm not going to do integration because of many of you told me that no one have done, I mean, some of you haven't done integration or differentiation, so I just skip, okay? So expected X will be expecting half of A and B, okay? In the middle of A and B because uniform. And the variance is a little bit complicated. It will be minus A squared over 12, okay? And I will not prove this too. I will just highlight where the proof, what kind of method we're using, just where goes principle, because not everyone know calculus, but I want to highlight those part that if you really go for it, study by yourself, you still understand what's going on. So let me go to the next one. So this is the graph when you have A is 2, B is 3, the length is 1, so the height is also 1. And if the height is 4, so if the base is 4, the height is 1 over 4. So that is what it means. This is the example. I just add, but it's very simple example. Number accident each day follow uniform between 1 and 4, right? What is the expected number of accident? Okay, so the mean will be 4 plus 1 over 2 is 12.5. And the variance will be 4 minus 1 over 12, right? Square is 3 over 4. So there's nothing but just some simple application, okay? And here is the simple proof of this, okay? I just will go very quickly. So basically this is constant can be taken out. So, and I just said once how you calculate this. This is using the integration concept of this, okay? For those who know, then you know. For those who don't know, don't worry about that. Just apply this directly, you will get this result, okay? I'm not going to go into detail of this, but this is how you prove it, okay? Because I don't think it's worth the class time to go for integration. If you don't know, that would be too tough, okay? Just highlight the main point that require integration. And x squared the same, so it's because if we have this, okay? So that's why 2 become 3 here, okay? So that's why 2 become 3 here, okay? I'm not going into detail for this. In case you have more question, you can ask me after the class, because I guess this is too technical for our class. So here, just variance will be just the difference between the two. So it's very straightforward. We are not going to go to that. I hope that's okay. I'll just give you some idea what's going on here. Now I want to spend some time on this exponential because the exponential is related to Poisson. Okay, remember the Poisson. Okay, Poisson is an approximation of normal, right? Is over the period of time. Okay, you divide them into small interval, right? As small as you want, the n interval of them, and we say there's maybe one event happen in small interval, right? There's two choices. Either you have an event or you don't have event. You have event is p, you don't have event is 1 minus p, right? It's a binomial trial here, right? So what happened here is np is bigger than 0, n go to infinity, and p go to 0. This binomial will converge, go to Poisson, right? And what exponential here means is the time until an event happen, because first one you might or might not happen, second one may or may not happen, right? Because this p is very small, so it's likely that the first quite a few times there's nothing happen, right? And there's something happen at this interval, okay? And then we will call this is the time at this interval, right? Until this time until happen. How many period you wait until one event happen. So if that follows Poisson, and the time until the event happen will follow the normal, will follow the exponential. Okay, so that's either exponential. Okay, and this exponential, later you will see the density function here is very close to in the Poisson, right? Because Poisson, remember, is like this, right? But after the right, so this is closely related to this guy. Okay, and this is a decreasing function, right? Usually what you see is something like this. Okay, depend on lambda how it looks like, and this is f, right? So it's area under the curve will give you probability. Okay, and the decision function, right? Follow this. Okay, so you can easily based on this decision function to calculate probability. Okay, so that shouldn't be a big issue, right? So I expect you know how to do this, right? And you don't need to do integration, right? Because when I ask you what is probability between A and B, right? Then it's very easy. You will see is B minus A, right? And for these two, you know how to plug in this formula. Okay, so that is something you don't need to do integration because this already provide you the solution for that. And we don't have time to prove it as we do the uniform, so that will be the mean will be 1 over lambda, and B will be 1 over lambda square. So remember, there's a typo in the old version. There's no 2 here, just 1 over lambda square. Okay, so make sure that there was a typo in the previous version. I mean, in the version that uploaded in the Blackboard. Okay, there's no 2. Any question? So basically, what you need is to know this is the distribution function. This is a mean, this is a variance. This one you don't need to remember because you don't know to, unless you want to do integration by yourself. Otherwise, this will be fine. Okay? Demo yourself clear? Any question? No? If no, good. Then we are going to give you the diagram, right? If you have the mean is smaller, right? Because the mean is 1 over lambda, okay? This is 1 over 2, right? This is 1 over 5, right? For this 1 over 2, the curve is higher, right? Because the mean is smaller, right? And for this one will be much better, okay? But I guess you don't really care about this graph, but just to show you how it look like. So this is the application usually we would be facing. The time for next customer arrive follow exponential, okay, with mean 20, okay. Here, to be careful, mean 20 actually means lambda is 1 over 20, okay, because mean is 1 over lambda, okay. What is customer arrive in the next 10 minutes, okay. So the probability that x less than 10, okay, that is f of 10, okay. And just remember, we have to remember this formula, right, is e negative lambda x, okay. So that's why you put lambda is 1 over 20, okay. X is 10, so it gives you the answer, okay. So that is something usually you model it with the exponential. Is that okay? Any question? No? Okay, that's good. So basically you need to know how to operate this function, right? And know how to collect the mean and its variance, and that is the thing you need to know. So I just very quickly to tell you the proof where the trick are. Here actually we involve a, if you learn integration, that involve what we call integration by part. Okay. So the key here is I just talk about it for those who are technically inclined. So if you don't know integration, you can forget about what I'm saying here. So you will be doing is e to the negative lambda x, that will be equal to, okay? So you consider these two parts, and by part will give you this answer, okay? If you don't know by part, or you don't know anything about integration, just forget about it. That will be the way to proceed. But just to note this, will give you 1 over lambda, okay? And in case you want to do math, you can try to go back and check. And x squared will give you the same. Here I use by part. Here is by part. So here I use by part. Okay. And once you by part, this guy, okay, is expected x. So that's why I give 1 over lambda. Okay. So there are the two key steps to prove it. For those who know integration, you can do it. You don't know, doesn't really matter. This is what we need. And that end up in the next slide is 1 over square minus 1 over lambda square. So that's why 1 over lambda square. So that is the things that you know how the variance formula comes about. And as I said, we don't require integration. So this is just for those who know integration. Otherwise, you can just skip those slides. Okay, as we said, this technical slide is safely to skip, but it's good to know. So if you don't feel comfortable with integration, so you can just you don't need to worry too much about those. Okay. Any question before we go to the normal distribution? That is a key thing we want to discuss. Okay. If no, then we just go straight to this one. Okay. And this one is a normal distribution, right? If those who know it before, this is also is called Gaussian distribution, okay? And this is invented by mathematician Gauss. And this is somewhat familiar with those who know what they call bell curve. Bell curve, okay? And probably you guys would be a little bit uncomfortable and not well known to you because I think now our school now use absolute grading, right? And at my times we use relative grading, right? And what you expect is, oh, this kind of people will get A, and this kind of people A minus, and this kind of people B plus, and this is B and B minus, and C plus, and so on and so forth, right? This is usually what you'd be expecting. Or I think you have the DSE, right? The exam also does this, I mean, five plus, right? And 5 star and 5 and so on and so forth. Okay. So that would be somewhat like this. Okay. So this distribution is have a support of negative infinity to positive infinity. Okay, that means any number. Okay, on the real line, and as we will show you this from the 2 weeks onward, we will tell you this is the most common distribution. Okay, because later what you learn what we call the central limit theorem. Okay, that is I think that's the most important result in this class, saying that a lot of things end up with a normal distribution. Okay, so that's why when you look at science, look at the nature, look at everything, say IQ, okay, in the society follow normal distribution, height, weight, a lot of things follow normal distribution. A lot of things actually follow this. And the good thing about this is it's so common. The bad thing about this is it's so common, but the density function is rather complicated. You will see for this one actually turn out to be rely on 2 parameter mu and sigma, turn out to be not surprisingly, when we run mu and sigma, this turned out to be the mean, okay? And this turned out to be the variance, okay? And for this one, right, the distribution function, this is the most of the thing you care. Turn out this is something we cannot do further. This is what it is, the best. We cannot do further, okay? How can we proceed? Of course, in the old day, we read menu, right? But now we have Excel, okay? Of course, or other software, okay? And then we can calculate this, okay? That's not a big deal for our purpose, but we'll be using the same idea we learned for the exponential to do all this thing, okay? So just to make sure you're okay, this is the mean and this is the variance. I will not offer proof for this because it's too complicated for our purpose. Okay, but just to remind you that this normal will have two parameters. One is the mu, one is the sigma. Okay, how they change your distribution? Let me go over one slide, and then I know it's already 6:15, but let me just talk about this particular slide before we're done, because over the weekend probably forget. Okay, just let me overrun it slightly. Okay, so this is look at the green one. Okay, mean is 0, mu sigma is square is 1, is that high, and look at the other one, -4, same sigma. So which means that the mu will determine the location of the bell. Okay, if negative, go to negative, positive, go to positive. Okay, and compare the green and the red one. Okay, this will be sigma square is higher, so it will be not so tall. Okay, so basically the mu will determine the location, the sigma will determine how high or how flat they are. Okay, and the next class, what we will continue is to tell you some property of the bell, like is symmetric about 0. Okay, and also interesting thing is normalization, which means if I given any normal distribution, if I standardize, which means I subtract its mean over its standard deviation, it's always the same. Okay, normal C1. That means that we only need to look at one table. Okay, always we go back to this 0, 1 standardized normal table, then we are done. Right? Otherwise, we have to invent many table, right? Because F depend on mu and sigma, right? Square. So we have many table, but turn out to be we don't need many table. We just need one table. Okay, I will leave it for the next class. If there are no question, so I will see you next week. Thank you and bye-bye. Okay, I'll stay around to answer any question you might have, but thank you and bye-bye. Have a nice weekend.
Hi, Professor.
Yes.
I have just recently joined this class, and I noticed that there will be a homework.
Sorry, can you go back? Can you say that?
Okay. I have just joined this class recently, and I noticed that there will be a homework next week. And can you explain more about it?
Oh, the homework, yes. So because I know you guys joined late, so that's why I make the homework have a long due day. So the homework is not something too complicated. Turn out to be just let me just wait a second. I just open the file for you. Just wait a second. So can you see the screen? Can you see the homework?
Yes.
So what the homework to do is you just need to produce a one-page report. Okay, a one-page report. And then you also have a 1-minute video to describe your finding. So what the homework asks you to do is to produce analysis to collect your own data, okay, or you just download from somewhere and you describe them using some chart, and you just tell me your finding. Okay, here you click the link and you can find what are the other people have proposed. Make sure that you don't duplicate with others. So what are the example? The sample, you can see something like this. So this is, you produce this kind of one-page report, and you can record video to tell me the main result. Okay, something like this. Or
so
something.
I just have to surf the internet and pick any findings that I would like to use.
Yeah, you just pick up the topic you want to do. I think the link is already there, but maybe I can, let's see if I can. I think that would be the link. I can send the link to you. You just declare it, just wait a second. In the announcement, the black box is there, but I can show you here. So let me share the screen. So this is the list of the topic other people have chosen. So just make sure you avoid exactly same topic that we find. You see what I'm saying?
Yes, yes, I see. How about the video? Should I record my face as well, or only my voice is okay?
Sorry, you collect your data is fine, or you download any data from internet will be fine. So you can see that a lot of people are there's data from talking about Hansen Index or stock market. You just do things you like, just to apply the thing you learn in the chapter 1 to 3, because we're not covering those things in the class. So that's why I wanted to do it learning by doing.
Okay. And how about the video? Should I record my face as well, or just
really
myself?
Just whatever you think that would present it well. We just can zoom on the can focus on your talk. Up to you. You don't have to.
Okay. Okay. Thank you.
Okay.
Thank you. Bye.
Bye bye.